Designing tables. Now, if you look at the objectives for this requirement, you'll notice there are a lot of them, and I'm just going to bring them up here in the browser just to show you. Here it is, designing tables. So there's a lot of them in here, but most of them we've covered in previous nuggets. Temp tables, temp variables, talked about CTEs, talked about GUID as a clustered index, performance implications of temp tables versus temp variables, set-based over row-based, table partitioning. So what we're going to do for this nugget is focus on the parts that we haven't covered, and that's really going to be around designing your tables, normalization and denormalization, encryption, something we haven't talked about, and then two really big and really cool features, file stream and file table. So that's going to be our focus for this nugget, and we're going to start here with a normalization overview so we can get the hang of what normalization is all about, how we should properly design our tables, talk about denormalization and when that will come into play, and just get a feel for the first three normal forms because those are going to be the most common ones that you'll see in everyday database design. From there, we'll cover everything else in what I've aptly named table design stuff. We'll talk about encryption. We'll get familiar with all the components involved in encrypting data at the column level. Then we'll also cover what file stream and file table are all about. It gives us a way to manage our unstructured data outside of SQL Server, but still accessible from within SQL Server. Then we will jump into the virtual nugget lab. We'll start with how to encrypt a column of data. We'll also get some best practices in there for backing up our service master key and our database master keys. And then we'll look at a couple of different ways to encrypt column level data. Then we'll see how to set up, configure, and use file stream. So we'll store that unstructured data on the file system and still access and use it from SQL Server. And at the end, we'll look at file table, a new feature here in SQL Server 2012 that's built on top of file stream and gives us another way to work with that unstructured data stored in the file system. Let's start with normalization to get an understanding of how to properly design our tables. Normalization. Think of normalization as just a set of rules that we can follow to ensure that the data in our database is efficiently organized. It's there to solve a couple of problems. The biggest one is redundancy. Redundant data is bad for a number of reasons. The big ones is obviously it increases storage space, but another one here is it decreases data integrity. Having data in multiple places opens up the possibility for inaccuracies. So that's a big one. It's also there to minimize dependencies, data and schema dependencies. If we put everything in one big table and down the road we realize, whoops, we need to break this out into a separate table, we've just created ourselves a nice little project because that will increase the time it takes us to redesign our database, especially down the road when it's been in production. Now we have lots of data to worry about, to shuffle around, and it becomes a painful process. So by thinking about normalization early and designing for it early, we can save ourselves a lot of time down the road. We won't be kicking ourselves when we have to deal with our own design. So when it comes time to design your database, it's really all about coming up with small focus tables that describe a specific entity. We don't want large tables that mishmash data, multiple sets of data into one, because that's what will cause problems with redundancy and dependencies. So that's really all it's about, just about creating a lot of small focus tables that are all related together. We should always start our database designs in the OLTP world as normalized as possible. It's a lot easier to denormalize down the road than it is to normalize down the road. And in the OLTP world, where the focus is entities, focus on entities, focus on describing an entity in small related tables. In the OLAP world, analytical processing, the data warehousing world, we want denormalized structures because it's easier for analysis. It's easier to write reports, and we get performance boosts by indexing the snot out of our tables. I know that sounded terrible, but it's true. In the OLAP world, data warehousing world, we don't really care about data redundancy, and we're not worried about insert performance. So big tables are absolutely fine and better for that world. Where the OLTP world, performance is of the utmost priority because our applications are real timing against our transaction processing databases. So that's another reason why we want them highly normalized, to increase insert performance. So it's all about insert performance in OLTP, all about read performance in OLAP. So we have these guidelines to follow set out by the community called normal forms. And most practical applications shoot for normal form number 3. There are more than that, but these are going to be the big ones, and these are the ones that Microsoft lays out in their curriculum as well to understand. So understand the first 3 normal forms, and you'll be good to go for designing a OLTP database. The first normal form is all about eliminating duplicate columns and repeating groups of data. Let's take an example. Let's say your boss walks up to you and says, "Hey, you, I need you to design me a table to track trainers and their courses." So your first design, you're like, "Oh, okay, we can do this." Well, a trainer can have many courses, so we'll just add a column for every course. Now, what happens when course 4 comes out? We're going to be making a schema change here, and that's bad because now we're going to have to go touch every query, every view, every stored procedure, every object that touches this table to make way for that new course. So you think to yourself, okay, maybe this isn't a good design. Maybe let's go with version 2 here. Let's make another table, only this time we'll have one course and multiple records for each trainer for that course. And you can see right away the problem with this design is redundant data. So horizontal and vertical designs in this case are bad. The right way to design this is to completely break them out into their own table. So we have a trainer table, we have a courses table, and then relate them together on a common field. This solves our duplicative column problem, and it solves our repeating group of data problem. So this is it. And the third part of normal form number 1 is to ensure that your tables have a primary key, which we do. And now we can create relationships between our tables based on that key. Normal form number 2. Now these are all cumulative, meaning in order to reach normal form number 2, you have to also meet the requirements of the previous normal forms. So normal form number 2 here is create separate tables for subsets of data. Now normal form number 2 is actually pretty straightforward, and it's all around redundant data. Identifying and removing redundant data by placing it in its own table and then referencing it from the original table. And a good example here is address information. Anybody see an address table out there with city and state tied to address and name? Yeah, that's bad because you're going to see city and state duplicated all over the place. So the right design here would be to break out our zip code into its own table that also contained city and state associated with it. Just store the zip, and now we can relate these two together like so. We reduce our redundant data being city and state. To accomplish normal form number 3, we have to meet normal forms 2 and 1 and eliminate fields that do not depend on the primary key. And we can do this by first taking our key field, so let's say that course ID is our key field here, and comparing it with all of our other fields. So does name rely on course ID? Absolutely. Category ID? Absolutely. Describes a category. Category name? Not so much. Category name relies on category ID, which relies on course ID. This is known as a transitive dependency because think of it like this. A relies on B, B relies on C, but C does not rely on A. It only relies on A through its relationship with B. So that's how you can identify transitive dependencies, and we have one here in category name. So in this case, we would break out category into its own table, course obviously into its own table, and again, relate these together. That'll remove any non-key dependencies that we have inside of this table. And a great way to do database design is design your structures. Remember, just focus on entity. I want to describe an entity and no more. Load it up with some sample data and look for those redundancies. If you find redundancies, try to further break that table down, and then it's just a matter of identifying the kind of relationships you have between your entities. One-to-one, one-to-many, many-to-many. Let's talk about some table design stuff. So this is just some of the objectives that we haven't touched on that we're going to take a demo on in the Virtual Nugget Lab, so I want to just get you familiar with them ahead of time. We'll start here with data encryption, which is a common thing to do when you're dealing with sensitive data, especially if you're storing things like credit cards or personal information. Then you may want to encrypt that data. And we do this by using SQL Server's hierarchical encryption infrastructure. Essentially how this works is everything is run off of the service master key. This is created when you install and first fire up your SQL Server instance. It creates the service master key, which is going to be the base for all other forms of encryption. It's hierarchical because each level is used to encrypt the level below it. So how this essentially works is if you were to set up encryption at the database level, you would be responsible for creating the database master key and then coming up with the method used for encrypting data. A symmetric key is used for both encryption and decryption. It's less secure, but it's also less resource intensive. So this is probably one of the more popular ways to do column level encryption in SQL Server because of that. An asymmetric key is more secure, but it's a lot more resource intensive, and it uses a public-private key pair. So you encrypt with one, decrypt with the other. Certificates are normally used with keys to relieve the whole password problem, and that is using passwords. Whenever you're using your keys, you're going to have to pass these passwords around. Certificates are this trusted object that essentially is a container for our password, and it's a lot more secure to pass certificates around than it is to pass passwords around. The most common encryption configurations are going to be, again, either just using a symmetric key or using an asymmetric key that's protected by a symmetric key. Which method you choose for your configuration is really going to depend on performance, if it's going to be an issue or not, and security. How secure do I need my data to be? And also, to an extent, key management. And as a best practice, we should always back up our service and database master keys. I'll show you how to do that in the virtual Nugget Lab. Let's move on to FileStream. So FileStream was this cool new feature in SQL Server 2008 that allowed us to store unstructured data. Now, to really understand why we needed FileStream, it helps to understand where we were before FileStream. So before FileStream, if we wanted to store, say, video or audio or image data or Word documents, PDFs, all that unstructured kind of data, if we wanted to store that in SQL Server, we could do it one of two ways. One, stuff it inside of a var binary or image column. The problem with that is performance. SQL Server is terrible at streaming that kind of data out of the database engine, and we would clog up its buffer pool with this kind of data. So that was most of the time undesirable unless you were storing small amounts of unstructured data. The second way of doing it would be to just simply store a path that references the file on the file system. But the problem with that is we no longer have transactional consistency. We're not linked between the data, our pointers that we're storing in SQL Server, and the actual lob data sitting on the file system. So if somebody moved a file or deleted a file on the file system, we'd have an invalid reference inside of our database. So FileStream solved both of these problems by allowing us to store unstructured data on the file system, streamed from the file system, while having it referenced and stored, its structure and location stored inside of SQL Server. So the beauty of this then is that applications could find and get the data through SQL Server, but it would be streamed to the application from NTFS. So we have transactional consistency because anything we do to those files through the application get deleted in SQL Server. Now, the only problem with FileStream, I shouldn't say problem, it wasn't complete at the time, was that SQL Server shielded everything. We couldn't actually access the file system. The only way to get files into here is through Transact SQL or through an application. The only way to get files out, through that application. We had no direct access to the file system. So it would be SQL Server actually managing all of this underneath this FileStream hood. And it is worth noting that developers as well could access that directly to stream those files to their applications through an API. Now, this is where File Table comes into play. File Table is this new feature in SQL Server 2012 that really just extends FileStream. It gives us another way to access the data. So rather than this being shielded and being inaccessible, File Table allows us to work directly with the file system, or users to work directly with the file system. So we would create this file table, which is just a fixed schema table in SQL Server. SQL Server creates all the columns it needs to. It's fixed. We're not defining columns or anything. We're just essentially creating a table and specifying a directory. Then SQL Server essentially links this table to your directory. Anything you do in this directory is reflected inside of the table. So users can work with files in there, put files in there, delete files from there. Developers could work with files in there or work with the table in SQL Server. So we've got just another way to work with the data, and we can work with it directly in the file system. And again, anything we do on either side is reflected on either side. Another really cool thing is that it actually opens up a couple of features in SQL Server, namely full text search. We can open up full text searching capabilities against our unstructured data through SQL Server using File Table, which is really cool. All right, with all that said, let's head into the virtual Nugget Lab. Let's see how we can encrypt column level data. Then we'll see how to set up and configure FileStream and use it, and then the same with File Table. All right, we're in the virtual Nugget Lab. Let's bring up SQL Server Management Studio. We have a new project, 14-Design Tables, and let's start here with encryption. So first, we're going to create a database master key here in the Nugget Demo DB. Then I'll show you how we can encrypt with just a symmetric key. Show you how we can encrypt with just a certificate. Then we'll use a symmetric key with a certificate, and then I'll take you through some best practices here with backing up both our master key, our service master key, and our database master key. So we're going to start here by creating a master key at the database level. Let's switch databases here to our Nugget Demo DB. Again, by doing this, it's going to use the service master key to encrypt it. And it's worth noting that the master key and the service master key are both just symmetric keys. So let's first create our database master key. There it is. Now we can create just a regular old symmetric key. Let's give it the name NDDB test key with an algorithm. You can specify your algorithm here. We're going to use triple DES, and we're going to encrypt it by password here, and there is our password. So let's create that key. All right. And now, and by the way, you can see your symmetric keys here by going into security, symmetric keys, and there it is as our key. You can also see the service level key in the master database in the same spot, and you can see that it is a symmetric key. Now, you can't see your database master key in the SSMS GUI. You would have to use a DMV for that. So now that we created a symmetric key, we can open it with our password, and then we can use it to encrypt some data. So we're just going to encrypt data, store it into a variable, and then we will select that data to see the encrypted version, and then we'll use the decrypt by key and also convert that data back to a varchar, and that will give us the output. So we'll be able to see our encrypted data and decrypt it if successful. Will give us the decrypted data, which should say some top secret data, and then you always want to close your key as well here. So let's do this. Open key, declare variable, encrypt data, store it in that variable, and then select the encrypted data along with the decrypted data, and then close our key. There it is. So while that was great and easy to do, the big problem there is we're passing around passwords in clear text. Why use a password at all when we can use a certificate? So let's create a certificate. Just a very simple one here. And then we're going to create a new symmetric key called NDDB key with a different algorithm, AES256, and we're going to encrypt it by using our certificate. And so you can see there's no passwords anywhere in here because we're going to open our symmetric key, decrypt it by the certificate. We're going to update our trainer table and set our certifications equal to our encrypted value. So encrypt by key, pass in the key GUID along with the key that we just created. That will retrieve the GUID and will encrypt our certifications column by our key that is currently open here. And then we will output the encrypted information just to a select star from trainer. That'll give us everything in that table. We should see the certifications column is encrypted. And then we will decrypt it with a query by calling decrypt by key, passing in our column and converting it to an nvarchar max as certifications. And the result then should be encrypted output, decrypted output, and then we'll close our key. So let's do it up. Hit execute. Here is our encrypted version right here. Look at that, nice and encrypted. And then if we scroll down here, here is our decrypted version. So that's it. Encryption isn't that bad to work with as long as you understand all of the components that go along with it. And it's really just, again, going to come down to performance, key management, and level of security. Now, I wanted to show you a best practice here. Best practice is always good to back up your keys, the service master key and the database master key. And you can do this pretty easily. Just run a backup service master key statement, send it to a file, encrypt it by a password, and there you go. You now have your symmetric key as a backup stored in the file system. And we'll do the same thing here with our database master key. Same exact thing. So if we ever had a problem and need to restore these keys, or if we were migrating databases around, we now have these keys available to restore. And to restore them, it's just simply running the restore versions instead of to file from file, and then you'll need to decrypt by password instead of encrypt by password. And that's that. Let's head into the file stream feature. So to enable file stream, we need to do it in two places. First at the service level, then at the instance level. So let's head in first to SQL Server Configuration Manager and enable it at the service level. You can do this by heading into the properties of the database engine, and you will see a file stream tab. So to enable it at all, you need to enable it for Transact SQL access. Then you can also open it up for File I/O access, which will open up a share. And this is the share that developers can use to stream it from the Win32 APIs. You can also enable it for remote clients. So I'm going to hit OK here. If you did change any settings that are different, then you may need to restart the SQL Server Database Engine service. We're good to go since we already had it enabled. So let me show you how to enable it at the instance level. And you can do that using good old SP configure here, passing file stream access level and the access level, which is going to be 0, 1, or 2. And you can actually see this in the UI too. If you head into properties, go into advanced, and here it is. Here's your access level. So there's 0 disabled, 1 Transact SQL, 2 full-blown access. So we'll leave it at full access. We could also just run this to double check, and it is changed from 2 to 2 there, so we're good. And so now that it's enabled, the next step is to add a file stream file group, which is going to host the directory that SQL Server is going to use as the root to store all of our unstructured data in the file system. So let's do this. Let's add a file stream group, or a file group called FileStreamFG. And the trick here is that you're going to have to add the FileStream attribute by doing a contains FileStream. That will mark it as a FileStream file group. You can actually see this if you go into the database properties, head into file groups, and here is our FileStream file group. Notice it's down in the FileStream section rather than the data section. All right, so with that up, now we can add a file to that FileStream group. And this isn't really a file. We're actually adding a directory. So we're going to specify that this FileStream directory is going to sit inside of our Nugget Lab files here. And just to double check, we always want to make sure that this directory does not already exist. It does not. It's empty, because if it did, we would get an error. So let's do that. That will create that directory. If we head back here, look at that, there it is. And SQL Server already puts some files in here to track metadata and then a log file. So when we create a table that has FileStream column in it, it is actually going to add the table in here as a unique identifier. I'll show you where that unique identifier comes from. And then for every column we add, it's also going to add another folder under there. So it's going to create its own logical structure inside of here, and it's going to use this directory as the root. So now that we're all set up and configured and ready to go, we can start creating columns that are of binary data type tagged with the FileStream attribute. Now remember, it's not going to actually store the unstructured data in here. It's just going to store a pointer to where that data sits on the file system. So we're going to make a brand new table here. We'll call it unstructured data. We could also alter, if we wanted to here, our Nugget table. This would actually be a good idea, because we have the old way of doing it here in video paths. So we could add another column in here called video that's the actual file stream pointer to the video file sitting on the file system, and that would give us all the benefits that we would want with transactional consistency and streaming that file from the file system. Now, there is one little hitch here. Any table that's going to contain a file stream column needs to have a row GUID column that is marked as unique. All right, so you need a unique row GUID column. It's the only hitch. So let's create our own table here called unstructured data inside of Nugget Demo DB. And look at that, it worked. So that's a good sign. If you can create a table here with a row GUID column and a file stream column, then you're good to go. You know you're good to go. And now what we can do is insert data into this column. So let's do it. Actually, before we do that, let me show you what that did. Even just creating that table with that video in it, if we head back here, look at this. There is the unique identifier for the table, and here's our column. So if you had more than one file stream column, there'd be a folder in each. So as we put data into that column, it'll start filling up inside of here. So let's do that. And what we're going to do here is I have a little unstructured data sitting inside of our directory here for this nugget. Unstructured data, video.mpg. So it's a 10 meg file. And let's do it. Let's upload it. There it is, one row affected. So we know that data is in there. In fact, if we just do a select star, we should be able to see it. There's our row GUID. There's the video, which is, again, just a pointer to where it is on the file system. Now, if we head into the file system, head into file stream, there's our table, there's our column, and there is our file, same size, 10 megs. So you can see with FileStream, we can't actually access the data in the file system. It's there. It's just there for SQL Server to use. And again, for developers to stream out of SQL Server without using SQL Server's database engine. So that's FileStream. It just gives us a way to store our unstructured data in the file system, but still access it through SQL Server. Now let's take this to the next level and talk about how to get file table up and running. So again, for file table to work, we need to have FileStream fully enabled just like we did. And from there, we can start enabling file table. Now there's one more setting we need to do at the database level. We need to set our FileStream directory name equal to a directory name that's going to be the root for all file tables in this database, and then also set up your non-transacted access if we want people to access this information outside of SQL Server. So let's do this. Let's alter the database, specify our directory, specify non-transacted access. And by the way, you can do this in the GUI too here just by right-clicking on the database, going into options, and here it is. So what that did is if we go to the file system here, and let's just type in the name of this server here, SQL Nugget Lab, and there is our file stream share, and if we go into there, there it is. There is our directory containing nothing right now, but if we were to create a file table, which is what we're going to do next, within a file table, every time you create a file table, you're going to specify your directory. So we're going to create a file table called Nugget Files with a directory called Nugget Files, and let's just switch our database here to Nugget Demo DB and try it out. And what that'll do is that'll create a file table. You can also do this here in the GUI. Here's file tables. There it is. But just keep in mind, if you do a new file table, it's just going to open up Transact SQL for you. So doing that creates a table, a file table, that sits on top of that directory. Because now if we go into our unstructured data directory, wrong one, we'll be to that one in a second. Here is our unstructured data. If we refresh it, there's Nugget files. All right, so there's our directory. And now what we can do is load files into there. In fact, that's what I was going to show you here. If we go into our design tables directory in Nugget Lab files, I have an unstructured data folder. In here, we have our CBT logo. Let's just drag this into there. Now, what that did is not only load it here inside of our Nugget files directory, but it also loaded it into our file table. So how cool is that? Watch this. If we do a select star from Nugget files, we get that one record. There it is. Cool. So now we can work with files from both angles, Transact SQL and from Windows, and they're both synced. Whatever we do in either one will reflect in the other. And just keep in mind, you can right-click on your table here. You can explore file table directory. It'll take you right there. That's pretty cool, too. And then you can also, of course, view your rows from here. And there it is. There's everything about that record. And let me show you how we can load a file from SQL here. I'm just going to create a variable called SUMData of our binary that we're going to put into that variable SUMData going into file table file system. Then we're going to insert directly into this table from SQL Server, giving it a file name, and then throwing the data into there. All right, so what this will do, if we execute it, and then we head to the file system into our Nugget files and refresh it, look at that. There is our file. And now we can also work with that file here from SQL. We can mark it read-only from SQL if we want to, because we've got some flags here inside of this Nugget table that allows us to work with it. See this? We can work with it. So we're going to mark this as read-only, for instance. And if we do that, we go back to the file system, Nugget files, let's refresh it here. We should be able to see if we go to the properties that it is now marked as read-only. So file table is awesome because it gives us not only the ability to store unstructured data outside of SQL Server, but it also allows us to access that unstructured data from outside of SQL Server. Great stuff. In this CBT Nugget, we learned how to design tables. We started off with a normalization overview where we got familiar with the most popular database design technique. We saw that normalization brings organization to our database and helps us reduce data redundancy and data dependencies. We also got familiar with some table design stuff required for this objective, namely encryption, file stream, and file table. Then we got familiar with how to work with each one of them. We jumped into the virtual Nugget Lab. We saw how to work with encryption to encrypt a column of data, how to use file stream to store unstructured data outside of SQL Server, accessible via SQL Server. And then we saw how to use the new SQL Server 2012 feature, file table, which just enhances file stream so we can now work with that unstructured data from the file system. I hope this has been informative for you, and I'd like to thank you for viewing.